You're doing these two questions. Yep. Oh, minus. You still could have done it the other way. It should have worked. You did the other. You did the negative 18 on top. Still should work. And you need negative 18 minus 2, which is 16. Right? If you had flipped the equations, you would have negative 18 minus 2, which is 16. Negative 16, sorry. And then you would have had 13 minus 5, which would have been positive 8.
Negative 8.
No, you'd get... Yeah, you can do it the other way. Like you could do flipping. You go negative 18 minus 2, which would be negative 16, right? Then you do 13 minus 5, which would be positive 8. You divide them out and you still get 2. Yeah. Negative 2, right? I don't know. Must have accidentally not negated a negative or something. But it would still work. Yeah. Yeah, so I told you this 2 sums of an arithmetic is a good chance it'll be somewhere on a test, right? We've done it like 400 times. Probably 2 more. Then the last one I gave you is missing R, because R is the hardest one to find. So I'm sweet like that. The sum of the infinite geometric series means we use S equals T1 over 1 minus R. S is 81. T1 is 27, and I'm making you find R. So what did I tell you to do when this happens? Yeah. Bring this one down, bring this one up, because we're going to multiply by 1 minus R, and we're going to divide by 81. So we're going to get 1 minus r equals 27 divided by 81. So that's 1 minus r equals a third. And then we subtract 1. Negative r equals negative 2/3. Divide by negative 1. R equals 2/3. So we're going to look at this in the general formula without actual numbers in it. So it says here if we have f of x equals a, x minus p squared plus q, what's the vertex always? Do you remember? It's always the opposite of this, same as this, because this tells me if I go right or left, correct? It's always the opposite of which way. We figured that out yesterday. And then q made it go up or down. So my vertex is always p, comma, q. It's always the opposite of this, same as this. Yeah. And then the direction of the opening, if a is greater than 0, it's up, right? If a, up, correct, I meant to say. If a is less than 0, it's down. My domain is always, for quadratics, unless the word problem, x such that x is an element of the reals. If the parabola is concave up, that means it looks like this. My range is going to be greater or less? This is the minimum. So it's, where's my arrows, guys? Up. So it's not less. It's greater. So it's going to be y such that y is greater than or equal to q. Whatever the heck this back number is. YER. And when it's down, concave down, it's a maximum. So what's it going to be? Y such that y is less than or equal to, still q. Because q is the y of the vertex, which is what this is. And my axis of symmetry always equals x equals the x of the vertex, correct? And what's the x of my vertex in this question? P. So that's general if I didn't have any numbers in it, right? We're going to look here. So this gives the graph of it and all. So here, we have f of x equals negative 2, x minus 3 squared minus 1. What does this tell me? It's down. So a would be less than 0, so concave down. My vertex, it's drawn down here for me. My vertex is at 3 and negative 1. We agree? Let's go compare that to the graph, or to the equation, sorry. Remember I said you take the opposite of this, same as this for my vertex. So x minus 3 is going to become positive 3, right? Because it moves 3 to the right. And negative 1. So do you see how it flipped and stayed? This gets me the vertex. It's going to be a positive 3 and negative 1. So my q always stays the same for my vertex. And my P always flips because it went the opposite direction, remember? If P was positive, it actually went to the left. If P was negative, it went to the right yesterday. So my vertex is at 3 and -1. My axis of symmetry is at x equals the x of the vertex. What's the vertex at? 3. What's my domain of every quadratic unless it's a word problem? Yeah. A set of x values such that x is an element of the reals. And this range is going to be y such that y is, remember this graph is concave down, it shows it above. So what's it going to be? Less than or equal to, and what, Carson? -1. -1, yeah. YER. It's always the y of the vertex, right? Or in this case, we can see it's at -1 or less. Right? All my y values. You try the second one. For this one, let's go over what we know. This is a positive A, and because it's a positive A is greater than 0, it's concave what? Up, which it is. You can see it. My vertex is going to be at what and what? Opposite of this, so -1, same as this, -2. We agree? This is called vertex form. Why is it called vertex form? It's labeled really well because it gives you the vertex. It's crazy. Vertex form. So, -1, -2. If it's not in vertex form, for now, you're going to have to type it into your calculator and find the max or the min, right? That gets you your vertex as well. If it's in vertex form, you get it really quick. So -1, -2. And look down here, -1, -2, right? What's my axis of symmetry? X equals the x of my vertex, which is -1. So the graph x equals -1 cuts it in half. X equals graph, or x equals lines are vertical, right? So that makes sense. It cuts it in half at x equals -1. My domain is always x such that x is on the reals, unless it's a word problem, which it is not. And my range is going to be y such that my lowest vertex here is at -2 or higher. So it's going to be y is greater than or equal to -2 YER. And then we're going to flip over. Your page is right beside. So look at the page or flip it over if it's your next one. We're on page 5. Okay, big chart. Look here. Let's do this. So the first one. What's the vertex of the first one? Opposite of this, which is 1. Same as this, which is 1. We're not going to worry about transformations right now. We'll leave that column blank for now, okay? What's the axis of symmetry at? X equals 1. Just the x of the vertex. My domain, D, is going to be x such that x is an element of the reals. And my range, well, I need to draw this to figure out if it's a max or a min. So I go to here, and I say, is it a max or a min? Is it concave up or concave down? Concave up, so my arrows are up, so my graph is getting bigger. So it's greater. If the arrows are up, my range is going to be greater. If the arrows are down, my range is going to be less, right? Because all the numbers keep getting greater. So my range is going to be y such that y is greater than or equal to, and what's my y? It's right here. 1. YER. So I get my range from the y of my vertex and the axis of symmetry from the x of my vertex, right? The x of my vertex is where my axis of symmetry comes from. The range comes from the y of my vertex. What's my vertex for this one? Opposite of this? Same as this. Yeah, -1, 3. Is this concave up or concave down? Up because it's a positive 2. What's my axis of symmetry? X equals the x of the vertex, which is -1. My domain never changes unless the word problem, which is not x such that x and out of the reals. My range is going to be y such that y is, where are my arrows? Up. And what does up mean in inequality? Greater. So it's going to be greater than or equal to my y of my vertex, which is 3. Yeah. Make sense? Okay, you guys try the next 2. The next 2. Then we're going to go to the next one. So you try the next 2. So this one has a 1 in front, so it's concave up. My vertex is at opposite, so 3 and 2. My axis of symmetry is at x equals 3. My domain is XER. And my range is y such that y is greater than or equal to, because the arrows are up, y of my vertex, which is a 2, YER. And then this one, once again, concave up. It's the opposite of this, same as this, so -5 and -3, because it's in vertex form. X equals -5. My domain is going to be x such that x and down to the reals. And my range is going to be y such that y is greater than or equal to, because the arrows are up, the y of my vertex, -3, YER. Now, these next ones, this one here doesn't look like it's in vertex form, but it actually is. Because the x is just like this, correct? And the x is just like this. So, when asked what number's in front of here, we put a 1, right? Because if it was a 0, it would cancel the whole thing off, wouldn't it? But if I have nothing with the x, I actually could write my vertex form out like this, which usually helps people. -2. When there's nothing with the x, when there's no brackets, that's the same as writing x plus 0 squared. So when you see nothing with the x, when x is by itself, you can write it, and it's squared. You can write it as -3 x plus 0 squared. Do you see that? Because x plus 0 is just x squared, right? It didn't change it. That makes sense? And when you write it out like that, it often helps get the vertex a lot better. Now, I know we say this is a negative leading coefficient, so it's going to be concave down, correct? And we always say opposite of this, same as this. But do we ever write -0? No. So we'll just write 0 and -1 anyways. So if there's nothing by the x, your vertex starts with 0. Then my axis of symmetry is x equals 0. My domain is x such that x and down to the reals. And my range is y such that y is what this time? Arrows are going down. Less than or equal to my y of my vertex, which is -1. YER. You're going to try the next one in a second. We're going to bump down to this one first before you try that one. Can you look at this one here? So I have a P. P is what's beside my X, right? But I have no Q at the back, do I? What's my Q if there's no Q? What could I put back here? If I put a 1, it would be there, right? 0. So if there's nothing, I have to put nothing, right? Like there was nothing with my X, so I could put X plus 0. So if your P or your Q are missing, they're zeros. Okay? If your P is missing, you can go X plus 0. If your Q is missing, you can just go plus 0 at the back. So you try filling those 3 out. So the first one, my vertex is at 0 and 4. My axis of symmetry is at x equals 0. My domain is x such that x is now in the reals. And my range is going to be y such that I have to go back and say, oh, it has a negative leading coefficient. Oh, it's concave down. Oh, my arrows are down, so my inequality is going to be less than. equal to my y, my vertex, which is 4. Y, yeah. This one is going to be at 5, 0. Opposite of this, same as this. It's concave down as well because of the leading coefficient. It's going to be x equals 5, the x in my vertex. My domain is going to be x such that x and L are the reals. And my range is going to be y such that y is, arrows are down, less than or equal to the y of the vertex, which is 0. Y, yeah. And then this one, concave down again, negative leading coefficient. My vertex is at 6, 0. My axis of symmetry is at x equals 6. My domain is going to be x such that x and L are the reals. And my range is going to be y such that y is less than or equal to, because the arrow is going down. And then the y of the vertex is 0. Your assignment is there, I just want to make sure I don't include the transformations on these. So it's going to be 1, I don't like 1. We're going to do, just ignore that. We're going to do 3. It says describe how to sketch the graph. Well, how are you going to sketch the graph? You're going to have to find your vertex first, which is your what? Max or your min, right? Go to your table of values, pull values off, plot graph, right? That's what number 3 is. You have to show how to graph it. I'm going to make you do 3A and C. Number 4, you're just not going to have to find any x-intercepts. So no intercepts. It says for intercepts, we're not there yet. So no intercepts for now for number 4. And then number 6 and 7. So for number 4, 6, and 7, where it says intercepts, to find the x and y intercepts, we're not doing that right now. Okay? So you're going to get working. You have 3A, C, 4, 6, and 7. You do everything but the intercepts. So that's for vertex, domain, range, axis of symmetry, etc. Okay? Get working. As long as you're working, I won't move on to the next thing. If not, I'm moving on to the graphs lesson, which is next. Equation of a graph.